Welcome guys, I'm Gio here, hope you're having a great day, and in this video we explore flatten function. This is not a very common function, it's certainly useful but in a very specific cases. So to explore that I have taken a piece of code from my old project and we're going to try to refactor this and see some common patterns and use the flatten function. So let's jump right into code. Now, let me give you a bit of context about this data and where this function came from and what's the intention. In MongoDB, we can have aggregation pipelines where we take the data from different sources, and one of the steps in a pipeline can be unwind operation, unwind step. And here we have this implementation here in JavaScript on a front-end project that does this step, this unwind. Now, how this step works, well, let me show you first and it will be easier to explain. So here we have the data, and for each piece of data we have characters array. For some of them we don't have it, but that's okay. Now let's run this code and see the result, and then I can explain what this unwind operation does. Now, as you see, in the final result, we have every character taken out from this sub-arrays and we have it as a separate object. So here, for example, in this case for Witcher, we have Geralt. It's a separate object. It also contains the details of the game. So for every item inside the given property inside the characters is taken out of this array, and this object, this main object if you will, is duplicated. Same is true for the second game, Red Dead Redemption 2. Each character is taken and new object is generated with the name of a current character and this main object. And here for the last game we don't have characters, so it's just kept as it is. Now this is, as I've mentioned before, one of the steps that can be used in a MongoDB pipeline when we aggregate the data from different sources, and in a certain cases that can be useful. But this function here I have taken is from a front-end project. I haven't personally implemented this and I don't know why it was there. I have certainly never used it in a front-end application, but it was there and I thought, well, that's interesting, and let me explore that. So, this is what the unwind operation does, and here we have this implementation. Now let's take a closer look. Initially we have the resulting array that will be returned, and then for every item inside the items we are going through this, and inside we are generating sub items, and then we are pushing them into results. So it's okay, it's good, it gets the job done. There is nothing wrong with this function, but in this video we try to rewrite it several times and see a common patterns and eventually use the flatten function. Now, first thing to observe here is that we have a list, and this list is transformed into something else, another potentially larger list. So, as I've said countless times, this is a good place to think about reduce function. So let's start with that. So what do we have? Well, we are using reduce function for our items that we receive, and we also have the field. And initially, of course, we have empty array because there is nothing here, and we will be adding our accumulated result into this initial value as we have in first implementation. Now, what do I want to achieve here? Well, first of all, I have to kind of unwind our current item. I have to go through each sub items here and generate this unwinded version of current object. So let's do that. So what is this? Well, For the current item, or for a top level object here, we take the sub array, whatever that field might be. So we have, this is a parameter. In this case, it's characters. So we take this and we are, in some cases, this field might not exist. So we are defaulting to an empty array. In this case, this game doesn't have characters, so it's an empty array. And then for every item here, we're generating object. And this object is current item, current top level item that we have taken as it is. And then we are replacing our field, in this case, characters, with current sub item. And sub item is this. We have this unwinded version of current item. Now we want to accumulate this into a final result. Well, how can we do that? Well, that's very easy. So we take whatever is in final result, take it as it is, and then we are adding into resulting array our unwinded version. And using the spread operator is one of the ways to achieve that. So let's just test this function and see if it's working. It seems to be working, but we are missing this game here. And in current implementation, if there is no field for given sub items, we are just taking the object as it is. So to fix that, when we have this check for defaulting to, instead of defaulting to an empty array, we can default it to array which just contains null. And if we run this again, we will receive that game without characters, and here in the characters property just will be null, and that's okay. We retain the game and it's still there, but this field is null, and that's cool. This implementation here is working, certainly. We are getting characters, and for each character we have also the details of the game they belong to, and that is good. Now, if we take a closer look at this implementation is more concise. It is using a common pattern called reduce, and I personally prefer this version. Instead of using this for each here, it has the same problem as regular for loop, that any number of things can be happening here, so it's not instantly clear the intention of this, while in this case we use reduce and we already know that we are taking the items and transforming it into something else. Now I want to push this further, but to do so I will have to use lambda.js. If you're following along, make sure that you have included this into your build or script or whatever you're using. I have this library here included, lambda.js, so I can use its functions. And first thing I want to do is to isolate this operation to unwind a single object, single item, single top level object. So I will define this function first and call it unwind1. Now this is the skeleton for our function for unwind1. It should replace what's going on here. And why do I use curry? Well, we'll see in a moment, but I want this function to be curried so I can apply these parameters here one by one without calling the actual function. And also I'm going to be using the pipe function from Lambda, and this item, our current item, will go through the pipe. So first of all, we want to take our field, so our sub array, from our item. So let's do this. So this here is basically this operation that we're doing. So we are taking the sub array, in this case characters, but it can be any property, so it's variable, and that's why we have the field. Now we want to check and default to this value if this field is not present. So let's do that. Okay, very good. Now we have this. So we already have this array taken. Now let's go through each element in our subarray and generated unwinded version. So for each sub item, we are generating a new object. We are taking a high level object here, the top level one, which is game in this case. We are taking whatever properties it has as it is, and we are replacing field with our current sub item. So let's first test this function on one of our games. And that is great, because for our first game we have its unwinded version. We have characters, and every character includes the details about the game that is coming from parent object. Now let's use this function and start generating our final version of unwind FP. Well, this is the skeleton for unwind FP2. Here we are passing field and items as well, and we're gonna be using the pipe function in this case, and this value, these items will go through our pipe. So let's start implementing the steps for pipe function. Now, first thing I want to accomplish is that for every item, for every top level item here, I want its unwinded version. Let's check the result quickly and then explain what's going on here. Now, it seems like we've got some kind of result, and this is expected. Here we have array of arrays. So for every item here, for every top level item, we have generated sub arrays. That's what unwind one does. That's why we have array of arrays. So this is one sub array, this is another sub array, and this is the last one, which just contains one item internally. Here, as you see, we are using the function unwind1 that we have implemented previously, and because this is a current function, I can just pass in the field here that I know will be used, but the later argument here, the item, will be passed by the map function. And you see how beautiful this is and how we compose this function to achieve desired result. Now, the last step to finish this implementation is to take every item from subarrays and make it just one array, so we get the desired result. And this is where a flatten function comes in. So let's edit here. Now let's run this again, and as you see, now we have received the final result. It's one giant array. We have every character here, and every character includes the details of the game it belongs to. So this is it. Now what flatten does, as you already understand, it is taking the array of arrays, and it is taking items from subarray and flattens it into one big array. And this operation can be useful in specific cases. It's not as common as reduce or map or filter, but it's there. And I think in one of our future videos we might even implement this ourselves, because it's interesting to do so. Let's recap what we have achieved here. So this is the initial version of unwind. Then there is, I would say slightly better one with using reduce, but there are, as you see, still parts that can be improved. And this is the final version, where the problem is really broken down into small tiny pieces, as you see here, small tiny steps, and then reassembled them together. I really like this last one. I think it's really beautiful. And as I've already said countless times, functional programming for me is about small patterns, small known problems, is about composition, identifying the common problems and then reassembling them together. And this is, this implementation is expression of that. Once you get used to it, it's very easy to implement. And I have actually, my first implementation when I saw this was this one at this point. And then I was thinking, for this video, I was thinking, okay, maybe it's better to have some intermediate, implementation that we can transition to this. So yeah, once you think in terms of these small functions, then it's very easy to break down some complex problems into known steps, into known patterns and small functions. This is what we have done here. And if you look at this, it's not really obvious from this implementation that we could have something like this. But once you have these functions and the small patterns in your head and this type of thinking, then you don't even think about this. You just go there and implement this, and it's very easy. So that's it for this video. Hope you enjoyed it. Click the like button, subscribe, and share it with your friends.